Good afternoon, dear colleagues. We're glad that you responded to our proposal and you are attending this event. Of course, we would like to have a talk on. I'd like to show you our site where we are decontaminating soils, but unfortunately, the situation with COVID is still hard, so we are working online. The topic is very burning: contamination of the urban soils has a direct impact on population health. Contamination of soil with waste accumulating on the surface of the soil causes the formation of toxic substances. They evaporate and get into our lungs. It provokes different allergies and diseases, including cancer. Our seminar is dedicated to a very important topic. We would like to make a progress in our soil decontamination, and we are glad to have these speakers today. I would like to introduce Russian speakers. I will begin with Maria Sherbakova, Chair of the Standing Commission on Ecology and Nation Management of the Legislative Assembly of St. Petersburg. The Commission pays a lot of attention to soil contamination. Ivan Serebrit, Deputy Chairman of the Committee for Nature Use, Environmental Protection and Ecological Safety of St. Petersburg. Evgenia Koroleva, Director for the Ecological Bureau Cosmos, is online with us. We have Olga Pavlovskaya, Director of the Exhibition Project of the Director of EXPOFORUM International. She is the chief organizer of the exhibition Ecology of a Megapolis. Also, we have Andrei Gorky, very authoritative speaker, Deputy Director of the Directorate of the Federal State Institute and Directorate for the Organization for Eliminating Accumulated Harm to the Environment, as well as to ensure the safety of hydraulic structures of the Krasny Bor landfill. He has a vast experience, and all the information we have was obtained due to Mr. Gorky. Also, we have online speakers. Unfortunately, Alexey Petrovich Petrovich, who had to present EXPOFORUM and the State's Engineering University is ill. He fell ill with COVID, and Mr. Olygin will speak instead of him. Mr. Dovtsenko will present the technology of micro biological studies. It belongs to the Russian Academy of Sciences. And finally, we will hear the presentation of Vladimir Vershchev, who presents Technoterra company. Currently, it's one of the leading organizations carrying out a lot of engineering surveys, including ecological, geological, geophysical, geodetical, and hydrometeorological surveys. All these organizations unfortunately work beyond the territory of our city across Russia. Unfortunately, our Finnish colleagues are not here with us. We have them online. Saya Tilgren, project manager, will speak today. She represents development organization of Mikeli. She will speak on our project, and she will represent Finnish specialists. We will also speak today. Saya, the floor is yours. Saya, the floor is yours. Good afternoon, dear colleagues. Welcome to our webinar dedicated to represent development agency of the city of Mikili. Is a partner of the project. All in all, we have 4 partners in our project. We have the Southeastern University of Finland, the University of Applied Sciences, and we have partners from Petersburg Association of Technological Partnership and ITMO University. By the Transborder Operation Program, the project has worked for 18 months already, and it is to work during the same time. Here you see 2 projects of 2 goals of the project. These are the following: enhancement of transborder cooperation in the area of circular economy and environmental safety, and insurance of a sustainable growth in the border areas. The goal of today's webinar is enhancement of the information distribution about soil contamination of the region and microbiological rehabilitation of the soil. Today, we have 3 Finnish speakers: Sari Hamalainen, development engineer from the Mikili city. She will speak on the current state of the soil contamination in Mikili. Jarno Laitinen, a leading expert of Ambala. He will tell us about the sustainable methods. And our last presentation will be made by Perto Marcelan, head of the soil rehabilitation department from Dora Nova company. He will tell us about the cases, in situ cases from Finland. Here you can see my contact details. You will get them after the webinar. Please contact me, and I would like to wish you a fruitful and constructive webinar. Thank you, Sile. And now I would like to give the floor to Ivan Serebritsky. He will tell us about the soils in St. Petersburg. Good afternoon, dear colleagues. I'm opening my presentation. Dear colleagues, the St. Petersburg soil condition is a very burning issue. We all know that soil contamination is directly connected with the history of our city, with the history of city agglomeration. Soils accumulate every particle, every substance which were processed throughout the entire history of our city, and soils preserve this for a long time In St. Petersburg, in the Soviet time, the soils were monitored and investigated during the last decades. There were complex studies of the residential areas of St. Petersburg and the soils. In 2006, there was a law on ecological monitoring in St. Petersburg issued, and according to the law, St. Petersburg territory had to be continuously monitored, but for a long time this work was not carried out. And finally, in 2019, there was an evaluation of soil contamination in St. Petersburg carried out. Last year, 2020, the scientific basis was tested in the fields, and starting this year, we plan to carry out a regular monitoring based on the scientific grounds developed the previous years. These are assessment criteria we use to evaluate soil contamination. Also, here we have norms. We are guided by in the Russian Federation, so if you are interested, you can read it in my presentation. Here, in the picture, you see the results of the investigation of the territory of our city from 1990 to 2020. About 80 hectares were investigated. Petrochemicals, heavy metals, and benzopyrene were the main parameters to be assessed. Also, dioxin content was assessed. As a result, we produced such an integrated map. You see total concentration of contaminants in the territory of our city, and currently it is the only complex map telling us about soil contamination in our city. The work carried out in 2019-2020 showed a bit different results because the tasks were a bit different. Our goal was to find proper places for monitoring posts. So we also carried out some work for petrochemicals identification, benzopyrene identification, dioxins. You can see the results on the slide. So what are our outcomes? In St. Petersburg, the majority of soils in residential areas is dangerously contaminated, which is quite obvious. Historically, in industrial sites, contaminants were accumulated. For example, in the central area of St. Petersburg, in historical parts, we found mercury in the soil in the area of former gold plants, where structural parts were gilded in the past. Also, we studied the territories of the former stables. We realized that in the 19th century, horses were the main transportation means, and horses were treated, their diseases were cured with mercury, and we can see the traces of mercury in these areas where the stables were located. As for benzopyrene, in some areas, the figure was quite high, 8 times higher than allowable. In some areas, twice higher than allowable. In some areas, 5 times higher than allowable. Petrochemicals are quite local. As for dioxins, the total amount is from 7,000 to 5 nanokilograms. So in St. Petersburg, the figure is about 50 times higher than possible, than allowable. In order to carry out the program of monitoring in St. Petersburg, currently in accordance with the federal legislation and normative acts and the decree of the government of St. Petersburg on the implementation of state monitoring of the state and pollution of the environment, we have to monitor the atmospheric area, soil, the surface water of water bodies, and other areas. We developed tasks to identify 8 basic sites in 8 regions of the city. And the task was to identify the components to be monitored: petrochemicals, heavy metals, benzopyrene, and dioxins. Also, we studied the dynamics of soil contamination monitoring. We realized that within time, the concentration of contaminants is changing. As a result, we analyzed the situation with soil contamination in all the regions, and the results you see on this slide. We continued this work in 2020. However, the task was different this time. We needed to develop methods of monitoring, and we studied some additional territories in our city. The results you can see on this slide. Heavy metals, you can see 3 pilot areas studied in 2020, and the results of the study. This work allowed us to assess the dynamics of content changing in the soil of St. Petersburg. As for heavy metals, their concentration is decreasing within the period of 30 years. As for benzopyrene, the concentration is increasing, which is in line with the Rospotrebnadzor statistics. We see it from the point of human health, not from the environmental point of view. As for petroleum products, it's the same. As for dioxins, it's increasing, but it is within the allowable range. Last year, the Committee for Nature Use developed a concept of the monitoring system development for the period up to 2030. And soil contamination in St. Petersburg is one of the aspects of this monitoring. So several tasks were set, long-term observation and assessment of negative consequences, as well as the reasons of soil contamination. So different soil contamination levels were assessed and compared with allowable maximum and tentative levels. This work allowed us to identify 120 areas in all the regions of St. Petersburg to be studied. Also, key indicators in accordance with the monitoring program, including oil products, heavy metals, benzopyrene. So we plan to carry out survey in all these areas. So we are waiting for the results to compare. This is the exhaustive list of all the indicators to be monitored. You see that for different areas, the list of indicators is different, but the basic contaminants are to be monitored in all the areas. I would like to use the opportunity and express my gratitude on behalf of the committee to the companies who have conducted this work for 30 years, the Regional Geoecological Center and the JC Technoterra. I think representatives will tell us in detail about their work, but anyway, I would like to thank you for your contribution. Thanks for your attention, dear colleagues. Can you hear me? Colleagues, all the questions in the chat will be answered a bit later. All the presentations will appear on our website together with answers to the questions. We would like to continue with soil contamination in Russia. So the next speaker is from Russia. Andrei Gorky will tell us about rehabilitation of contaminated sites in Russia. Good afternoon, dear colleagues. Let's continue the discussion of soil contamination in Russia. So at the first stage, we identify concentration of contaminants in the soil. Then we have to take a decision what to do. So the problem of identification of contaminated areas is relevant not for Russia only, but for all the countries. Here you see some screenshots from Germany and from Finland. And the situation is quite the same. In Germany in 2005, 362,000 sites were suspected in contamination and only 13,000 were cleaned. In Helsinki, 200 sites in the city were being analyzed at that time. You see that in Russia, the scale of the problem is also quite high. In the 90s, in the European Union, there were quite a lot of programs dedicated to soil contamination. For example, a large-scale rescue program, which was finalized in 2005, and other programs, Chlorinated, Cabernet, Caracas, and some others. As a result, in Europe, there was a general opinion formed on the procedure on the legislation and each and every country, and it was captured in the documents. So starting with the 90s, the development of the regulatory basis in Europe was quite successful. In 1995, Estonia developed norms for soil cleaning. In 1998, in Germany, a law was adopted for soil protection, and in 1999, a description of the soil rehabilitation procedure was developed. In Finland in 2007, there was a governmental decree on the assessment of soil contamination, and in 2017, in Russia, a federal law was adopted on the assessment of accumulated harm to the environment. This is definitely about contaminated areas, contaminated soil. So if we have a certain contamination which negatively influences the environment, we can see this field, a field of accumulated harm. So this notion, accumulated harm, is related to contaminated soil. In order to manage these contaminated areas properly, we need to have three aspects very clear in the law. We need some quality norms. We have to have some benchmarks to compare. So in St. Petersburg, as the previous speaker said, we have certain areas contaminated 2 times or 5 times higher than allowable. So there is something to compare, some norms. Also, we need a procedure of assessment, and also we need a procedure of rehabilitation and purification. Well, I will not be able to tell you about everything, but I will try to outline the main procedures. So, quality assessment. First of all, we have to take into account the type of the territory. And secondly, we have to look at the consequences for human health. So in the Russian Federation, we have 3 categories of soil quality. And here you see quality categories adopted in Germany and Belgium. In all countries, there are higher risk areas, children playgrounds, and so on, and less important industrial sites. But anyway, approach is very much the same. We have to be logical. If we have different requirements to different areas, utilization, we have to have different norms. In Germany, you see different norms for playgrounds and industrial lands. In Slovakia, the same, they have 3 levels of quality assessment. In Estonia, we also have 3 levels. In Finland, we also have 3 levels: threshold value, lower guideline value, and higher guideline value. And this is situation in the Russian Federation. Here you see horizontally contaminant concentration, and vertically you see the risk. If the contaminant concentration is lower than allowable, we can use the land. If it is higher, we cannot use the land. We have to start with rehabilitation measures immediately. All we have in the middle is the risk assessment area. In Russia, we have the so-called threshold allowable value. It's a one-level system, which is quite problematic. We look at all the possible negative consequences for human health, and we take the worst to assess the soil. Direct contact with contaminated soil is not something which happens very often. Quite often we deal with contaminated soil indirectly via water, via food products. So finally, our norms, which we use in the Russian Federation, is not about our direct contacts with contaminated soil. These are heavy metals, for example, for 50% of cases, we have translocation criteria when we deal with the contaminated soil via food products. So when we say that in St. Petersburg, contaminant concentration is 2 times higher, 5 times higher, it only means that we cannot grow food products there. But it doesn't mean that contamination directly negatively influences people's health. In red, you see the territory in St. Petersburg, which is not in line with the maximum allowable concentration norms for lead. You can be shocked, but if we look at the German norms for playgrounds, for example, the picture will be very much different. If you compare our Russian maximum allowable level with those of Finland or other European norms, you will see that our levels, allowable levels, are very much the same with that of European countries. But you see that the levels which urge us to immediately start cleaning are very much different. In Russia, it's several dozens of times higher. This is the difference of approach in Russia and in Europe. Krasny Bor field is a good example. We have a lot of discussions about its contamination, but if we compare Russian norms with Finnish norms, we will see that we will not have any excessive contamination. The same about organic contaminants. We will see PCB or DDT. We will see some excessive contaminant concentration based on Russian norms. But if we compare it with the Finnish norms, we will not see any discrepancies, any excessive concentration. So all the norms are relevant only for residential areas. As for industrial areas, transportation areas, these norms are not related to them. This is a huge weak point. What about the regulatory basis for designing rehabilitation procedures? Well, we have a vast experience of such procedures. We have a lot of guidelines, European and even Russian guidelines. For example, in 2005, the Committee for Nature Use issued methodological recommendations based on the European experience. But in Russian Federation, all these procedures have not been put to practice yet. So first of all, we need carry out identification, then risk assessment, then remediation and monitoring. And this procedure is captured in our federal law on environment protection of 2017. So we are using the same procedure: identification, assessment, rehabilitation. We also have some rules for this work described here, but again, we don't have any final procedure. So we have certain rules for liquidation of accumulated harm, but at the same time, in the land code, we see that if the soil is contaminated, recultivation is required, which is guided by another law, rules for recultivation and conservation of lands. So the same procedure is captured in two documents in the Russian Federation, which causes a discrepancy. These documents are different in their volume as well. The first is 2 pages, the second is 8 pages. I believe that assessment and development of rehabilitation measures is quite a complicated task. So 2 pages is not enough, 8 pages is also not enough. However, we have some state standards. For example, we have a guideline for the study of urban and industrial sites for soil contamination, and we have a guideline for safety, which are in line with ISO, but they are not obligatory, these state standards. It's not an obligation to follow them. So the system of our norms, all in all, is not in line with the practical tasks we are facing to liquidate accumulated harm and contamination. The legislative basis is not well developed, and we still have to optimize it, to harmonize it with the European approach. We need information about the best available technologies of sanation, rehabilitation of contaminated areas, and we still don't have them. And last but not least, at our website, you can find all the documents I referred to. You can find European guidelines and methodological recommendations of the committee. Well, that's what I wanted to tell you. Thanks for your attention. Thank you, Andrei Vadimovich. So we've heard about the current state of soils in our city and problems of rehabilitation. Now we can talk about the decontamination technologies, so we can proceed with the speeches of our Finnish colleagues. Now I'd like to give the floor to Iona Riehila, Technical Director of Mikkeli. Unfortunately, we don't have our Finnish colleagues with us, only online. Ioni, the floor is yours.
Kiitos Boris. Hienosti sitoutit minua kuuntelemaan näitä mielenkiintoisia puheenvuoroja. Haluaisin tuossa alussa tuoda tietysti terveisiä täältä Mikkelistä. Olen tosiaan Jouni Riihelä, Mikkelin kaupungin tekninen johtaja, ja hyvin laajasti nämä asiat kuuluu minulle. Ikävä on tietysti se, että fyysisesti tällä hetkellä olen Mikkelissä mieluummin olisin Pietarissa, jonka olen oppinut tuntemaan kauniina elinvoimaisena kaupunkina, ja siitä varmasti kiitos kuuluu Boreksen vieraanvaraisuudelle ja erittäin nopealle ajokyvylle, josta olen saanut nauttia siellä ollessa. Mutta mä uskon, että tämäkin asia korjaantuu ja tapaamme vielä toisiamme. Erityisesti haluaisin tervehtiä puheenjohtaja Maria Srepakovaa, varapuheenjohtaja Ivon Sheremtskia ja johtaja Boris Krilovia. Ketään muuta osallistujaa toki unohtamatta, mutta erityisesti teitä. No kaiken kaikkiaan tämä aihe tänään on hyvin tärkeä ja puhdas luonto ja tavallaan siitä pohjautuva elinvoimaisuus, elintarviketuotanto, asuminen, kaikki, niin ne on Mikkelin kaupungille strategisesti hyvin tärkeitä asioita. Ja eräällä tavalla me nähdään nykyaikana, että nämä meidän pilaantuneet maat muodostaa eräänlaisen uhan luonnolle. Muistetaan, että me juodaan pohjavettä, hyvää pohjavettä, joka on tässä kaupungin alla ja tavallaan tuotantoalueella on pilaantuneita maita. Mutta se muodostaa uhkaa myös terveysturvallisuudelle, asumisen, erilaisen elintarviketuotannon, elinvoimaisuuden niin kuin näkökulmasta hyvin laajasti niin tälle alueelle. Mä uskon, että me ollaan hyvin pitkälle tunnistettu, minkälaista pilaantunutta maata meillä on, mikä on niin kuin tavallaan se syy sille pilaantumiselle. Me ollaan luetteloitu hyvin kattavasti meidän alueet ja tutkittu ja siinä määrin ehkä se uhan suuruus, mikä meille aiheutuu kaupunkina, niin on mun mielestä aika hyvin meillä tiedossa. Täytyy muistaa, että meillä on pilaantuneita maita, jotka on kaupungin vastuulla. Meillä on myös pilaantuneita maita, jotka on toimijoiden vastuulla, eli niissä kohtaa toimimme viranomaisina ja se ei ole varsinaisesti meidän oma operaatio. Mutta että me ollaan löydetty hyvin erilaisia metodeja poistaa sitä pilaantunutta maata, joka meillä on, ja toki on ajallisesti nopeampia massanvaihtoja, toki ehkä kalliimpia, mutta sitten on myös ajallisesti ja muilta arvoiltaan ehkä toisella tavalla muodostuvia, hieman hitaampia biologisiin prosesseihin liittyviä asioita. Se voi sisältää myös vähän matalampaa kustannusrakennetta. Mutta niin kuin tässä mun mielestä hienosti nähtiin, niin myös meilläkin ajatus on se, että kohteen jatkokäyttö määrää tavoitteet lopputulokselle ja sitten sen metodin tai polun, millä me sinne päästään. Ja usein jo yksittäinen tonttikin, saatikka kortteli, sisältää monia metodeja ja monenlaisia polkuja. Me halutaan tiivistää meidän kaupunkirakennetta, se olisi kustannustehokas. Me halutaan sitä, että se luonto, joka meillä on tässä rakenteessa, on puhdasta. Me halutaan rakentaa terveysturvallista yhteiskuntaa kaupunkilaisille, mutta samaan aikaan me ajatellaan, että se tulisi tehdä kohtuullisten kustannusten ja aikataulun puitteissa. Ja sen näkökulmasta mä uskon, että paljon tehtävää on sekä meille viranomaisille, mutta myös yliopistoille, yrityksille ja muillekin toimijatahoille. No kaiken kaikkiaan niin mä haluan tässä myös Pietarin kaupunkia kiittää, teidän viranomaisia, yhteistyötahoja ja muita, muun muassa yrityksiä yhteistyöstä, mitä me ollaan nyt rakennettu kahden kaupungin välillä ja erityisesti viimeinen vierailu niin siellä Pietarissa liittyi veteen ja puhtaaseen veteen ja tavallaan sen ympäristöön ja niin kuin me silloin kerrottiin, niin meille on valmistumassa, eli meillä on tällä hetkellä koekäytössä hyvin moderni jätevedenpuhdistuslaitos, joka muutama kuukauden kuluttua puhdistaa kaikki meidän yhdyskunnan vedet puhtaammaksi kuin meidän järviluonnossa oleva vesi luonnostaan on. No nyt kokoonnutaan pilaantuneiden maiden ympärillä, pohditaan kunnostusta ja erilaisia menetelmiä. Mä uskon, että Pietarilla ja Mikkelillä on hyvin samankaltaisia haasteita, niin kuin usein ollaan yhdessä todettu. Toki täytyy muistaa mittakaavaerot, mutta sitten myös isotkin projektit tehdään paloittain. Nekin syödään pienissä paloissa, eli tavallaan ne metodit ja ratkaisut on sitten skaalattavissa ja monistettavissa. Näin mä jaksa kaiken kaikkiaan uskoa. Kaiken kaikkiaan minusta on hienoa, ja Mikkelin kaupungista on hienoa, että vuoropuhelu on yhä laaja-alaisempaa, olen sen huomaavinani. Meillä on osaamisen vaihtoa, meillä on alustoja, joissa yritystoiminta voi saada puolin ja toisin mahdollisuuksia. Kaiken kaikkiaan niin kuin tulevaisuuden mä näen hyvin valoisana, ja kun mä nyt näitä kahta asiantuntijapuheenvuoroja tässä kuuntelin, niin jo pelkästään tämä iltapäivä osoittaa, että tätä vuoropuhelua kannattaa jatkaa ja ennen kaikkea kuunnella noita hyviä puheenvuoroja, jotka on vielä edessä. Näin mä haluan omasta Mikkelin kaupungin puolesta toivottaa kaikille hyvin onnistunutta seminaaria.
Thank you, Mikkele.
Kiitos Jere
Colleagues,
ja nyt meillä on
let's
suomalaisia
proceed to our
alustuksia.
Finnish colleagues' presentation about
Kuunnellaan
soil
Mikkelin
contamination
tilanteesta.
in Mikkeli.
Ensimmäisenä on
Sari
Sari
will tell us
Hämäläinen
about the
kertoo Mikkelin
situation. Sari, the floor is
tilanteesta. Sari,
yours.
oli hyvä.
Sari Hämäläinen.
Tervehdys kaikille. Kuuluuko mun ääni täältä ja näkyykö tämä esitys?
Kyllä kuuluu jo.
Kiitos. Eli kiitos kutsusta tähän tilaisuuteen ja tervehdys täältä talvisesta Mikkelistä. Kerron tässä teille niin kuin tästä maanomistajan näkökulmasta näistä pilaantuneista maista. Ja tässä on ihan muutama tämmöinen taustatieto niin kuin Mikkelistä kaiken kaikkiaan, että kuinka monta asukasta täällä on, noin 53 000 ja noin 32 000 neliökilometriä maata, josta sitten alle 700 neliökilometriä vesialuetta. Mä vastaan Mikkelin kaupungilla ympäristövastuupalvelun kautta näistä lain piiriin kuuluvista vastuista, pilaantuneista maista ja pohjavesistä ja toimin kaupungilla maanomistajan edustajana yleisillä alueilla sekä kaupungin omistamilla kiinteistöillä. Ja valvon kaupungin etua maanomistajan roolissa sellaisessakin pilaantuneen maan sekä pohjaveden tutkimus- ja kunnostushankkeessa, jotka toteutetaan kaupungin alueella, vaikka niiden toteuttaja, kunnostaja on joku muu taho kuin kaupunki. Toimin yhteistyössä eri tahojen kanssa, on sisäisiä asiakkuuksia ja maaomaisuuden myynnin ja oston yhteydessä tai rakennusvalvonta, ympäristöpalvelut on sisäisiä ja sitten ulkoisia on konsultit, rakentajat ja viranomaiset. Kaupungilla tehdään tämmöinen ympäristötilinpäätös yhteistyössä Mikkelin seudun ympäristöpalvelujen kanssa. Siihen kerätään tietoa vuosittain, mitä on kaupungissa tehty ympäristöasioiden eteen. Ja jos nähdään, että on tarpeen tehdä ympäristövastuuvaraus, niin tässä kohtaa tehdään sitten kaupungin tilinpäätökseen ympäristövastuuvaraus. Lyhyesti tässä nyt näistä toimintatavoista, miten Mikkelin kaupungilla näitä asioita hoidetaan, eli tilaan pilaantuneiden maa-alueiden historiaselvityksiä, maaperä-, sedimentti-, pohjavesitutkimuksia, kunnostussuunnitelmia teetetään. Niiden perusteella haetaan sitten pilaantuneen maaperäilmoituksella viranomaisilta lupa tähän kunnostustyön suorittamiseen. Saadaan pilaantuneen maaperän kunnostuspäätös ja sen perusteella sitten aloitetaan kunnostus. Yleensä nämä työt tilataan puitesopimuskonsulteilta. Ne on etukäteen minikilpailutuksen kautta sitten saadaan nämä konsultit kuhunkin kohteeseen valittua. Mutta ennen kuin ylipäätään mitään työtä aloitetaan tehdä, niin on hyvä ensin selvittää se, että onko kaupunki niin kuin vastuutahona näissä pilaantuneissa maissa. Että vaikka kaupunki on maanomistaja, niin se ei välttämättä tarkoita sitä, että kaupunki olisi ensisijainen puhdistusvastuutaho. Mikäli kaupunki on vastuussa hankkeesta, niin silloin nämä yleensä tehdään niin, että puitesopimusurakoitsijalla teetätetään nämä työt. Urakka kilpailutetaan näiden valittujen puitesopimusurakoitsijoiden kautta. Kaupungilla on pyrkimys myös hakea sitten rahoituksia näihin kunnostushankkeisiin. Niitä haetaan valtiolta, neuvotellaan vesilaitoksen ja yksityisten tahojen kanssa sitten myös näiden raha-asioiden järjestämisessä. Mikäli kohteen omistaa muu kuin kaupunki, niin hankkeessa saatetaan tarvita sitten yksityiseltä maanomistajalta tutkimuslupa siinä vaiheessa, kun tutkitaan alueita. Ja jos on tarvetta kunnostaa, niin sitten tarvitaan tietysti maanomistajan suostumus pilaantuneen maaperäkunnostukseen. Kaupunki voi siis tehdä yksityisen maanomistajan puolesta tämän pilaantuneen maaperäilmoituksen, jättää sen ELY-keskukseen, jolloin kaupunki toimii vastuullisena tahona tässä kunnostuksessa ja saattaa sen puhdistuksen sen saadun PIMA-päätöksen mukaisesti sitten. Mikäli kaupungin ympäristöviranomainen yleensäkin toimii kaupungilla niin, että yleensä näissä tämmöisissä äkillisissä onnettomuustilanteissa tai vahinkotilanteissa jälkipyykkinä, niin he saattaa osallistua näihin pilaantuneiden maiden tai muiden tämmöiseen tapaukseen tiimoilta, mutta niissäkin kuitenkin toimivaltaisena viranomaisena on ELY-keskus. Eli yleensä kunnostukseen vastuutahona on vahingon aiheuttaja ja näihin hankkeisiin sitten niin kuin pyritään ohjaamaan niin, että vahingon aiheuttaja palkkaa konsultin ohjaamaan sitä kunnostustyötä ja tavoitetasot sitten määräytyy ELY-keskuksen kunnostustavoitteen mukaisesti. Tässä minulla on semmoinen kaavio vaan siitä, että arvioituna, että jos ilman mitään tämmöistä niin kuin kiireleimaa, niin jos halutaan niin kuin hanketta viedä eteenpäin tutkimuksien kautta, kunnostustarpeen arvioinnin kautta, kunnostussuunnitelma, lupa-asia haetaan, niin tähän on yritetty vähän kuvata sitä, että kuinka paljon se aikaa ottaa, ja tämäkin saattaa olla hieman ehkä vähän alakanttiin arvioitu, että saadaan tuo prosessi vietyä läpi. Voi olla, että joissakin tapauksissa saattaa mennä jopa yli tuon 6 kuukauden. Sitten tässä on yleisesti ottaen niin kuin Mikkelin alueelta pyysin vähän tietoa siitä, että kuinka monta kunnostuspäätöstä yleensä haetaan täällä Etelä-Savon alueella, tämän viranomaisen alueella, niin kappalemäärällisesti nämä ei kovin suuria täällä ole ja keskimäärin kaupunki 1 tai 2 pilaantuneen maaperän ilmoitushakemusta jättää ELY-keskukseen. Ja sitten tässä vasemmalla taulukossa niin nähdään arviolta suunnilleen, että kuinka paljon tutkimuksia vuosittain tehdään, eli 2-3 kappaletta keskimäärin vuonna 2018 ja 2019. Ja sitten kunnostuksia on ollut noina vuosina yhteensä 3 molemmina vuosina. Ja arviolta niiden euromäärällisesti niihin on mennyt noin 300-400 000 euroa per vuosi. Tuo viime vuosi oli vähän poikkeuksellisempi. Siinä on tutkimukseenkin käytetty rahaa jo enemmän. Tässä nyt on mainittu yhtenä kenttänä nyt tuo Satamalahden ympäristö. Kerron siitä hieman lisää myöhemmin tuossa. Niin tuo 110 000 euroa ei ihan täsmää tuon 2 tutkimuksen kanssa, vaan niitä oli enemmän. Et kovin paljon ei täällä yleensäkään myöskään yksityisellä sektorilla tehdä kunnostuksia, jos ajatellaan, että noista Etelä-Savon alueen luvuista niin nämä 1-2 on ollut sitten Mikkelin kaupungin jättämiä. Vuonna 2018 halusin vähän kartoittaa tarkemmin tätä Mikkelin alueen, mitä Mikkelin kaupunki on tehnyt näitä maaperätutkimuksia ja kunnostuksia ja tämmöisen arkkispohjaisen työkalun kautta lähinnä tämmöiseen sisäiseen käyttöön kehiteltiin online-versio, Arkkis Online, josta saadaan nopeasti tsekattua, niin kun, että onko jollakin tontilla kiinteistöllä niin kun kenties tehty tutkimuksia tai kunnostuksia. Ja siihen saadaan tuommoiseen pop-up-ikkunaan nopeasti lyhyesti tiedot siitä, että onko se ollut tutkimus ja onko kunnostustarvetta ja milloin se on tutkittu ja kuka konsultti on tutkinut ja näin poispäin. Ja tämä on vielä hieman tämä työkalu vähän kehitysvaiheessa, että pitäisi sinne täsmentää ja lisätä tietoja ja saisi sen sitten vielä parempaa käyttöön. Tällä tavalla pystyy nopeasti niin kuin saamaan tietoa, jos vaikka rakennusvalvonnasta tai kaavoituksesta joku haluaa tiedustella, niin kuin, että onko jollain alueella tehty jo tutkimuksia. Sitten lyhyesti tässä, että minkälaisia kohteita yleensäkin Mikkelin kaupungissa kunnostetaan, niin näähän menee lähinnä niin kuin se edellä, että halutaan mahdollistaa rakentaminen tai turvata pohjaveden riskit poistaa tai sitten ylipäätään maankäytön muutoksen vuoksi, että halutaan yhdessä tontti, mutta sekin yleensä perustuu siihen, että siihen on todennäköisesti tulossa rakentamista, mutta harvemmin pelkästään sen ympäristön suojelullisen näkökulman kannalta on näitä hankkeita pistetty vireille. Ja tästä syystä suurimmaksi osaksi Mikkelin kaupungin maaomistuksessa olevien kiinteistöjen maa-alueiden kunnostukset on tähän asti lähestulkoon massanvaihtoa. Ja tämä johtuu lähinnä siitä, että näiden vastuiden selkeys on siinä suurin syy. Se on molemmin puolin sekä myyjän että ostajan taholta vähän ajateltu näin. No, haastettahan näissä tietysti niin kuin tuo se, että monestikin halutaan niin kuin kunnostaa ja puhdistaa niin kuin puhtaammaksi kuin mitä laki edellyttää. Ja se tahtoo sanoa enemmän kustannuksia kaupungille. Ja tähän liittyy nämä niin sanotut kynnysarvomaat, jotka eivät ole pilaantuneita maita, vaan nuhrumaita. Niin tässä herää iso kysymys siitä, että kenen vastuulla ne oikeasti on, kun ne eivät ole pilaantuneita maita. Ja lain mukaan, kun kaupunki haluaa toimia, niin periaatteessa kynnysarvomaat eivät ole kaupungin vastuulla. Haastetta tuo myös sitten rakentajien kanssa nämä aikataulujen yhteensovittaminen, että usein tulee vuoden vaihteen alussa tulee tieto siitä, että nyt tulevana kesänä jotakin ruvetaan rakentaa, niin tämä saattaa asettaa vähän haastetta siihen, että miten onnistuu kunnostaminen sitten, että jos aluetta ei ole etukäteen voitu tutkia tai ei ole ollut tiedossa edellisenä vuonna. Suurimpana tämmöisenä haastana tällä hetkellä näkisin kuitenkin näiden pilaantuneiden maiden ja niiden kartoittamisen lisäksi tämä maan seassa olevat jätejakeet. Että se on osoittautunut enemmänkin semmoiseksi kustannukseksi, suuremmaksi kustannukseksi kuin mitä pilaantuneet maat itsessään. Myös pohjaveden pumppaus saattaa olla semmoinen ennalta arvaamaton kustannus, mihin ei ole osattu varautua. No, haastetta asettaa tietenkin tämä kilpailuttaminen, mikä vie aikaa, joka saattaa aiheuttaa sitten tässä näiden rakennuttajien kanssa toimiessa sitten vielä ongelmia, mutta nyt toistaiseksi tällä hetkellä on nämä puitesopimusjärjestelyt on ollut meille se etu, että ollaan voitu tehdä hieman ehkä nopeammin kuin mitä olisi muuten ollut mahdollista. Pyrkimys tietysti olisi, että tehtäisiin vähän etupainotteisemmin näitä kunnostuksia, mutta monestikin se on kustannustehokkainta kunnostaa juuri ennen rakentamista, jolloin ei tarvitse tehdä niitä väliaikaisia täyttöjäkään. Ja monestihan näihin kehityshankkeisiin liittyy näitä haitta-ainepitoisia ja pilaantuneita maita, että harvemmin on kuitenkaan kyse vaan siitä pelkästään sitä puhdistushankkeesta, eli taustalla on jotain muuta, minkä takia niin kun alueelle halutaan niin kun tehdä jotain, halutaan rakentaa ja tätä kautta sitten niin kun pyritään kuitenkin näiden muiden toimenpiteiden yhteydessä sitten teknisesti ja taloudellisesti, mutta myös kestävästi kunnostaa. No, yleensä ottaen, mitä tässä 5 viimeisen vuoden aikana olen Mikkelin kaupungille tehnyt pilaantuneet maiden osalta töitä, niin on havainnut kuitenkin niin kuin sen, että kovinkaan suurista pitoisuuksista ei ole kysymys, että enemmänkin tässä on niin kuin ehkä taustalla se, että halutaan poistaa näitä vastuita niiden pilaantuneisiin maihin kuin että keskitytään niinkään ympäristö- tai terveysriskiin. Muutamia esimerkkejä tässä nyt sitten. Esimerkiksi Koiralahden jätetäyttö. Tämä tuli Mikkelin kaupungille juurikin sitä kautta, että on yksityinen maanomistaja, pilaaja ei ole selvillä. Ja tässä on selkeä pohjaveden pilaantumisriski. Pumppaamo on niin lähellä, että haluttiin varmistaa tämän Suomenniemen pohjaveden tila. Tosin ei ihan mennyt niin kuin suunniteltiin tämä kohde, että kustannukset kolminkertaistui ja työn loppuvaiheella huomattiin, että täyttömateriaali on liian painavaa, jonka vuoksi sitten tämän tiimoilta jatketaan hanketta pohjaveden ja painaman lisätarkkailuseurannalla vielä tämän kevääseen asti. No, esimerkkinä myös toinen kohde, mikä on tullut Mikkelin kaupungille tämmöisen neuvottelujen ja kuulemisen kautta. ELY-keskus lähestyi vältettiin hallintopakkomenettelytoimenpiteet tällä, että vapaaehtoisesti sitten otettiin tämä hanke niin, että haettiin se sitten valtion jätehuoltotyöksi ja toivottavasti sen kautta sitten päästään myös kunnostustyö suorittamaan tässä tämän tulevan vuoden aikana. Esimerkkinä myös tämä Satamalahden ympäristökehittäminen. Mä taannoin vuonna 2018 myös teetätin tämmöisen kartan tästä Satamalahden alueesta. Mikkelin keskusta on tuossa kartalla niin kuin vasemmalla ja Satamalahti ympäröi. Nämä vaaleanpunaiset maa-alueet on niin kuin Mikkelin kaupungin maaomistuksessa olevia maa-alueita. Ja tämän perusteella sitten kaavoitus on tämmöisen kilpailuohjelman mukaisesti jakanut tämän Satamalahden ympäristön 4 osa-alueeseen sekä tuohon vesialueeseen. Ja tässä on lyhyesti informaatiota tuosta alueesta, niin kuin mikä osa siitä on kaupungin omistuksessa ja suunnilleen, että mihin kukin osa, onko kaupan ja teollisuuden aluetta vai asumiseen suunnattua aluetta. Ja tässä nämä maa-alueet vielä tälleen vähän niin kuin havainnollistamiseksi esitettynä tällaisella kartalla. Tosiaan tuo vesialue on tuossa keskellä sitten. Tämän hankkeen tiimoilta edettiin niin, että pidettiin 3 konsultin kesken tämmöistä vuoropuhelua. Siihen osallistui myös kaupungilta muitakin minun lisäksi. Pyydettiin tarjouspyynnöt tutkimussuunnitelmista ja vuoropuhelujen jälkeen sitten kilpailutettiin nuo tutkimussuunnitelmat ja tavoitteena oli, että saadaan vuoden sisällä siitä sitten niin kuin tutkimusraportit. Siinä kaiken kaikkiaan meni noin 13 kuukautta. Tässä vielä lyhyesti tämä prosessin eteneminen. Pidettiin Teams-palavereja, keskusteltiin tämmöisistä ylipäätään, että mikä on tavoite, tutkimussyvyys, jäteen luokitus. Se saattaa vaihdella aika paljonkin riippuen tahosta, joka kirjoittaa raportteja tai näin. Pyrittiin tämmöiseen yhtenäiseen esitystapaan ja haettiin siihen vähän semmoista
mikä aika rientää.
Joo. Tutkimukset maksoi kaiken kaikkiaan Mikkelin kaupungille noin 100 000 euroa ja nyt puhutaan vain näistä kaupungin omista maa-alueista. Tässä on sitten lyhyesti esitettynä, että mikäli näillä alueilla nyt sitten ei tehtäisi minkäänlaisia toimenpiteitä tai suunnittelua ylipäätään tästä, että jos vaan pilaantunut maa-aines kaivettaisiin pois, niin kaiken kaikkiaan 3,4 miljoonaa euroa olisi nuo kunnostuskustannukset, ja tuossa ei ole mukana sitten vielä vesialuetta. Tässä vähän lähinnä historiatietoa siitä, että ensimmäiset arviot on tehty 2013. Ja tämän vuoksi sitten tässä haluttiin myös sitten tehdä tämmöinen riskialuekartta, että mikäli tuolla Satamalahden alueella halutaan tehdä jotain kehitystä tai toimenpiteitä edetä jollain alueella, niin sitten tässä esitettiin ne alueet, että missä sitten vähäisemmällä riskillä voi aloittaa ja mitkä vaatii vähän enemmän suunnittelua. Sitten Mikkelin keskustassa on yksi kohde, josta on tässä nyt lyhyt informaatio siitä, että tämäkin oli semmoinen, että ainoa vaihtoehto tässä kohteessa oli tämä massavaihto. Ja tässä kohteessa sitten voidaan sanoa, että tuo seulonta oli sellainen millä saatiin aika hyvin tätä tehtyä tämmöistä lajittelua. Ja alustava kunnostusarvio oli noin päälle 400 000 euroa, niin tämän seulonnan ja tämmöisen lajitteluansiosta päästiin sitten tässä kohteessa alle 200 000 euron. Eikä saatu minkäänlaisia valituksia, vaikka toimittiin ihan torin laidalta noin 500 metriä, niin sinänsä kohde onnistui loistavasti. Tässä ihan muutamia kuvia tästä, että minkä tyyppistä siellä oli, että siellä oli aika paljon rakennusjätteitä, haudattuja rakenteita, kellarikerros, rautarobua. Ja sitä tehtiin tosiaan erottelemalla kaivinkoneella ja sitten ihan käsin lajiteltuna. Tässä on lyhyt videonpätkä tästä seulakauhosta, jonka avulla saatiin hyvittäinkin tämmöinen jätteellinen maa-aines ja jätejakeet eroteltua niin, että tämä pystyttiin ajamaan maakatopaikalle, joka säästi aika paljon tässä kustannuksia. Kiitoksia. Spasiba.
Thank you, Sari.
Kiitoksia, Sari.
Now,
Ja nyt siirrymme
let's turn
seuraavaan.
to the experience of soil purification from petroleum products. From company,
Yeah,
Alexander
Alexander,
Olivin, the floor is yours. Good afternoon, dear colleagues. Alexander Olivin, EcoProm company, St. Petersburg. Please put on your presentation. I can say a couple of words about EcoProm company. It's one of the oldest companies here. For about 30 years, it has worked. It's the environmental protection field. They are working with biological purification methods primarily. EcoProm has worked in this area for 30 years. Indeed, during this time, we have been in all the regions of Russia. And we have worked in different geographical and climatic conditions. EcoProm deals with not only soil purification from petrochemicals, but also we do some survey work, design, construction of water supply and sewerage systems. As usual, soil decontamination involves the following: ecological investigation of contaminated territories, recultivation project development, and carrying out work of decontamination. I would like to tell you about 3 projects EcoProm has fulfilled recently. Ulan-Ude city, the Republic of Buryatia, is the first case. Situation with contamination is the following. on the right bank of the Selenga River, at the outskirts of the city, an industrial conglomeration was formed, which during a long time had been contaminating the territory, which led to the following: together with groundwater to the coastline of the Selenga River, petrochemicals were brought. On the slide, you can see that petrochemicals penetrated the waters of the Selenga River even in winter, during the time when the water was frozen. But this is not the worst picture. Sometimes the oil spill spreads across tens of dozens of meters. We investigated the territory. We investigated 2.5 kilometers of the coastline. Here's a chemical survey and drilling technologies were used. As a result, we identified a spot about 300 meters, which was the most contaminated one. The soil was in very bad condition. Except for that, except for the coastline, we investigated the territory from the source to the Selenga River. Gas and chemical survey showed an approximate direction of petrochemicals from the source of contamination to the Selenga River. To liquidate the process, we designed a project which allowed at 2 levels to protect the Selenga River, which flows into the Baikal Lake, actually. First of all, in the project, we designed a network of water wells to conduct the water and to intake the water in order to extract water from the contaminated area. At the coastline, we planned to construct a lateral drainage system, which is a trench 1 meter in depth and width, which is filled with gravel, and there is a drainage trench there, the upper part of which is filled with cane bones. So the project has been fulfilled. Here you see local sewage plant. There are 5 modules there of continuous water decontamination. And you can see in the right picture a drainage trench organized along the coast of the Selenga River, which is filled with cane bones. As a result of this work, we achieved the following. When we made drainage trench, we extracted a lot of contaminated soil. Every year, cane bones impregnated with petrochemicals were extracted from the trench and replaced with new ones. 22 tons of cane bones impregnated with petrochemicals were utilized. Except for that, 79 tons of water and petroleum mixture was extracted from the underground. As a result of the environmental monitoring, we realized that during the period of work from 2015 to 2018, the average capacity of petroleum-bearing layer dropped 3 times. The quality of the water in the Selenga River has improved, and as a result, the quality of the soil along the coastline has improved as well. The project is not finished yet. After the final liquidation of the petroleum-bearing layer underground, after an additional investigation of the coastline, the soil there will be recultivated. The next site I would like to speak about is located in Kurgansky region. As a result of spillage of a furnace fuel from the boiler room around the area of 2 hectares in the forest area, there were local spots contaminated with petrochemicals. We developed a project and we decided to carry out recultivation and biological treatment of the contaminated soil. In the picture, you see focal points of contamination. You see they're scattered around the site, and you see what we have done according to the project. We installed the recultivation field, the recultivation site. Here is the state of the soil contaminated with petrochemicals and excavation of the soil. After 1 year of work, we extracted contaminated soil and performed a complex of biotechnological works. As a result, the initial concentration of the contaminant in the soil dropped 2 times. Another site is located in Sverdlovsky region in the forest area. As a result of leakage, there were local spots contaminated with petrochemicals formed. According to the working project, we plan to decontaminate the soil by two methods: in situ without extraction of the soil, and with extraction of the soil with further cultivation in the field. Here you see the preparation of the cultivation fields. And this is extraction of the soil contaminated with petrochemicals. Placement of the soil at the cultivation field. Condition of the soil after the first year of work. After we introduced structurators, mineral fertilizers, and bioagents. Here you see contaminated areas where we performed the cultivation without soil extraction. We plowed the ground. We introduced peat. And then we treated the soil biological. As a result, at the recultivation field, we decreased petrochemical concentration 2 times, and at the biological treatment site, without soil extraction, contamination concentration reduced 3 times. The work is not finished yet, it will be continued. Most probably, we will need 2 or 3 seasons to decontaminate the soil fully. These are the results of our work. Thank you, Alexander. If we have any questions, we will send them to you. All the questions will be answered. The next presentation will be made by the representative of the Rumble company, Jarno Lainen. The floor is yours. Jarno Lainen. Sorry, if you can hear me. Do we have Jarno with us?
Thank you very much. I'm here just a moment, so I set up the audio and video.
Please still try to stay within the timeline.
Good afternoon, everyone. I believe my presentation is now visible. I will be telling today shortly about in situ remediation methods and integrating sustainable development on remediation. My presentation will be a bit more top level. I will not go into technical details on a very high and very detailed level, but instead I will try to describe an overview of how a remedial options appraisal goes forward in selecting a remediation method and how to take sustainable development into account on the remediation selection process. The presentation structure will follow the following agenda. I will first give you a short introduction to the terms Then we'll talk briefly about options appraisal, then about sustainability in remediation. And at the end, I'll give you some practical examples and showcase a tool that has been developed to implement sustainability practices in remediation. First of all, throughout the discussions, you will hear the terms in situ, on-site, or ex situ. These fundamentally mean operations where in situ, you do the remediation on-site without excavating the soils or moving the groundwater. On-site remediation, you will probably do some excavation and remove the contaminants on-site to the top of the soil and conduct the remediation there. But on ex situ remediation, you do not only excavate the soils or remove the groundwater, but you also take them to another facility like landfill or a soil treatment plant to be treated further. So thinking about soil remediation methods, they are generally divided on 3 different categories on a basis of their mechanism. We talk about physical methods, biological methods, and chemical methods. The physical methods are mainly based on changing the contaminant from one phase to another. So for example, stripping volatile contaminants from water to gaseous phase and then extracting them. The biological methods are mainly based on the microbial skills of using these contaminants as part of their metabolism. A good example would be a microbe consuming petroleum hydrocarbons or oil hydrocarbons and producing carbon dioxide and water as an end product. And chemical methods are mainly related to chemical oxidation reduction reactions. A good example would be using a strong chemical oxidant to break the linkages in petroleum and oil hydrocarbons. Such oxidants could be, for example, hydrogen peroxide, which can be found in small quantities, for example, in washing detergents. So when we start looking into what kind of different methods we have on these under physical, biological, and chemical methods, there is a large variety. I will not go through of them. I will just let you see briefly what kind of options there are. But one of the most common methods is with the soil excavation. Excavation and removal and final placement on a landfill. And if you look at the list of available methods, excavation is only one among very many. So thinking about how these different methods can be applied at different places. Here is an example that we have at a building and an oil heating tank that has leaked underground and in the water. So of course, one possibility for remediating the oil tank is just excavating and removing that. Then when we are in the vadose zone under the building and we don't want to tear that down, we could consider, for example, chemical oxidation. And then going along, the oil has penetrated the groundwater as in moving along with the groundwater. We could use, for example, biological remediation and with the help of microbes, degrade the contamination. If there is some gases coming and they might come into the building, we can use some structural methods to remove the odors and the risks from those. And then if the plume continues, we can either try to monitor this, the natural degradation, or build some kind of reactive barriers trying to prevent the flow of contamination. And as a risk management method, for example, for a contaminant spreading far away and where we don't know the origin exactly, we could use, for example, a pump and treat method to extract and divert the contaminated flow. Or for gaseous contaminants that might threaten the building and the safety of people within, soil vapor extraction would be a good option. So how do we move forward on selecting a method for remediation? The step number one is to identify the methods which would be suitable. So this means identifying what kind of remediation methods could potentially work for the contaminants in question. The number two is to assess their appropriateness to see whether this method could be applied on this site. If the economics are good, if the soil is the right type, if there is no other infrastructure that would hinder the remediation. And now that we know the methods and we know the limits, then we make different options out of this. For example, meaning that I will excavate this part of the property and then I will use in situ remediation at this part of the property. And then usually still at this stage, you have a few options. So then you have to choose which one is most suitable for the project. And if we think about how to identify what kind of methods are best suited, so it's best to start from the contaminant. So look into the contaminant actually, that is this a contaminant that can be remediated with this method? Not all contaminants can be treated with all methods. We have to understand how much contamination there is and where is it located. We have to understand if the site is suitable, if it's big enough or small enough, if the soil type is silt, sand, till, where the groundwater is. And then we have to compare that whether the goals for the risk management are actually achievable with this method. So it is very different that if we have contamination at topsoil, where we might consider some composting or plant-based remediation, or if it's in the groundwater and it's already threatening the municipal drinking water facility. And then to know that if we actually know enough, if we know the site well enough, and if we know the method enough for this site. So now that we have somehow a background knowledge of what kind of an in situ methods there are, where they could be applied and how we could select them, and we have a pool of options, we need to choose the most suitable. In the recent years, we've been talking quite a lot in the Scandinavia and Finland about sustainable remediation. Sustainable remediation is the elimination and or control of unacceptable risks in a safe and timely manner, while optimizing the environmental, social, and economic value of the work. So fundamentally, trying to balance between the benefits, what we get out of the remediation, and the impacts that the remediation work has. So even in this seminar, we have been talking on most presentation about risk-based management. So what is the difference between risk-based remediation and sustainable remediation? If we look at the theoretical background, risk management, it has a very long background starting from 1970s, and it's based on economic scientific models that try in a transparent way find for a single target, a single goal value that tells us that do we need to remediate. But when we look at the sustainable remediation, it's more based on ecology and policies and politics. It's based on an ethical model that identifies that we need to find an equal way of setting targets and doing operations, because if I do something on one side, it impacts also other sides. And I have to do it not only effectively, but also efficiently. So whereas the risk management tries to answer that, do we need to act? Sustainable remediation tries to answer how we should act. I will try to describe this in a simple picture that shows that how the risk management and sustainability are not equal. So imagine you have a site where you have contaminated soil and you start remediating that towards the risk-based threshold value limit. As time goes by, you go forward with the remediation and you induce impacts, at the same time costs and other impacts to the economy, impacts to the environment, and impacts to the society. So where you have reduced the impact from the contamination, you have induced impact to other areas of our world. So summing up these, you have a sum impact. And even though you've achieved the threshold value and you've gained good risk reductions, you've only gained marginal benefits in sustainability. And very often we even tend to go there or we would like to go there that find the optimum spot where the sustainable remediation is, that the benefits from remediation are in balance with the impacts of work. So that would be the optimum spot. But very often we end up in a situation that we try to over remediate, take even the last parts away, where we might end up in a situation that we actually do more harm than we do good. So I will then move a bit faster to help get up speed for this session. There's a few simple categories that when you have to select the remediation strategy or remediation method that you can take into consideration. You can consider aspects related to the environment, to the society, and to the economy. So trying to find a balanced way of integrating the impacts into matrices like the air, the soil, the water, raw materials, health, safety, ethics, costs, flexibility, resilience, and find a balanced equation, which would then be probably give, if not help you selecting the method, help you identifying if there are potential sustainability problems with the approach you are selecting, and then would allow you to make a better solution for the society, for the environment, and for the economy. There is a few, this is apologies in English, but this tries to show you and link how you can use this kind of 6 simple questions to implement sustainable development to your remediation project. So, for example, taking questions about land. Look how much surface soil is consumed with the remediation strategy you have selected, how it impacts the land and soil quality, and what are the remaining geotechnical properties. Or in terms of health and safety, look at the long-term risk management performance, risks to site workers, or impact to larger public. And all of these, when you look, can be directly also connected to the United Nations Sustainable Development Goals, and then helps us in building a more sustainable future. Then I'd like to show you an example of what we do and what we use for this ourselves. We have a digital platform that helps us to make more sustainable remediation decisions. It's called Ramble Sure, and it's a decision assistance tool for landowners, remediation contractors, and designers and regulators that helps to make these complicated decisions more simple and helps to support the communication that is related to this remediation options selection. This is based on the ISO standard, so it has a global scientifically approved background, and it supports connection with the United Nations Sustainable Development Goals. So if you're interested in trying this out, it's free of charge. Please send me an email. And then for a short wrap up for the last slide, 90% of all remediation methods are based on physics, biology, and chemistry. They're either done in situ, on site, or ex situ. But still, when we try to remediate, over 90% is based on excavation. So by understanding the methods for remediation method selection, you can identify the right options that give you the right solutions for the project. So you can have a much more versatile pool of remediation methods, and which might then provide you with a more better solution. And then when making the final selection, do take sustainable development in account. That allows to make sure that you have a safe, economically viable, nature protecting and socially acceptable solution. And one way of doing this is with assistance of a digital platform like the Sure by Rambo. But from my part, I would like to thank you for the opportunity to present, and I will gladly provide you additional information if you wish. There are my contact details. You are quiet, muted, Mr. Chairman.
Boris. Jarna, thank you so much. The most interesting was the part dedicated to the balance between risk-oriented and sustainable recultivation. The next presentation will be made by Yuri Datsenko, Laboratory of Microbial Technologies. Yuri, please connect to us and please stay within the timeline. Good afternoon. Can you hear me? Yes, we can hear you. First of all, I would like to thank Boris for the invitation to the conference, for the possibility to speak. I will try to stay within the timeline. Screen, yes. First of all, good afternoon, everybody. My name is Yuri Datsenko. I represent Laboratory of Microbial Technologies, Moscow. I will speak about cleanup of contaminated soils using microbial technology. The problem we're solving is soil decontamination. As you can see from the map, the most contaminated areas are located in the historical part of the city, which is due to history. And except for them, we also have Krasnogvardeysk and Kolpinsk regions, which are highly contaminated with chemicals. We have the following numbers. Norms in St. Petersburg are broken. The numbers are from 4 to 10 times higher. I saw 90%. This is the percentage of soil recultivated by excavation. So recultivation is quite costly. type of work highly dependent on the weather. Of course, a lot of waste is involved with that. If we work within the city area. So all these are the limitations for using the method of excavation. However, 90% of the soil is decontaminated using excavation method. So what do we offer? We offer biological method. In situ rehabilitation based on the use of microorganisms without excavation, without replacement of the soil. Preparation of the project is 1 month. Installation of equipment 1 week. So the decontamination system requires a relatively small space. Our technologies allow to get the level of petrochemicals in the soil from 0 to 15%. So within a couple of months, we can decrease the level of petrochemicals down to the optimal level, allowable level. In our company, we developed an underground filter system. It allows to use microorganisms continuously throughout the year. So the tank with the agent is above the ground, and we make injections and we introduce the agent into water-bearing layers. Underground waters distribute our bacteria, so it serves as a kind of transportation. So the technology itself is about the following. Microorganisms work to decontaminate soil. First of all, we have to identify the contents of the chemicals in the soil. Based on this information, we select the proper concentration of our bio agent, and we install the system, activate our bio agent, and then we monitor the situation. We see how petrochemicals are decreasing. So we use water and non-pathogenic bacteria, which are not dangerous to people, neither for people nor for animals or plants. And no excavation is required. We do not touch the surface soil, which allows us to preserve all the plants and all the animals in the territory. So the soil is transferred from a dangerous category to a low risk category, which is within the accessible limits. This is experience of our technology use in 2014. So the technology involves microorganisms. They work at a temperature from 2 to 45 degrees, but we use a certain heating system due to which we can use our technology all the year round. Our institute is located in the Moscow region. We are working under the auspices of this institute and the Russian Academy of Sciences. The production platform itself is located in the Moscow region. This is a composition of our biological agent. Some bacteria penetrate the film on the petrochemical. They eat up the petrochemical, so this is done by Candida and Pseudomonas, and Rhodococcus does a cleanup. As a result, we have an active heat, water, and CO2. The speed of oxidation of hydrocarbons is 27% per month. So these are two samples of soil we took in the summer last year. One sample was taken in August, the other one in September. And photos are speaking for themselves. We took the first sample, which was pure petrochemical, and the other sample is water absolutely free from petrochemical, which this is a result we achieved for 4 months. Can I remind you the speed of work of our microorganisms is 27% per month. So depending on the concentration of contaminant, we can calculate in which time we can decontaminate this soil. These are the 3 parameters we use to report to our clients. Results of analysis of petrochemicals with underground waters in soils themselves, and the results of microbiological survey. These microorganisms we use have the so-called Aboriginal bacteria in their structure. These Aboriginal bacteria have lived before us and they will live after us. So these bacteria exchange information. Our bacteria teach Aboriginal bacteria to fight petrochemicals. They teach them to eat these petrochemicals. We design a unique cocktail of bacteria which is suitable for a particular type of soil. And this is the procedure of our working with the customer. Option number 1, a turnkey solution. We formulate the price, we calculate the concentration and time required for the work. The result we can achieve during 1 month. Second option, either selling our bioagent itself or a bioagent together with a decontamination system design, and our client builds it himself. So these are oil production areas we are working at in Russia and in Europe. As a result of working in Europe, we have a hygienic certificate. We also work in Libya, which is quite an exotic destination. The temperature of the soil is more than 60 degrees. So we treated the ground and the client decided that the result should be soil which was suitable for growing wheat. So finally, they grew wheat in this soil. So these are some photos. I cannot show you many photos because clients will not always agree. So it's 2014, Gazprom, Hunters. 2016, 2015, Gorlica in Poland. And this is 2020 in Petersburg oil terminal. We have been working since June 2020. The work is still ongoing. However, it's winter, it's -23. Anyway, our bacteria are working. Another technology. Biological decontamination of railroad gravel. So we treat the gravel in situ. Depending on the capacity of the station, we can treat up to 2,000 kilograms per day. So cleaning is done during shift. Our working solution is circulating all the time. We add a small quantity of our bacteria and work non-stop. So this is our system. Any car which can be connected to a system can be used. This is a result, the gravel at the beginning of the working day to the left and the contaminated gravel to the right. The end of the working day. So this is always me. If you have any questions, I will respond with pleasure. Yuri, we will receive the questions later on. Unfortunately, we are out of time. I would like to thank the organizers and the participants once again. So if you allow, we will place our presentation on our website. Now we turn to our Finnish colleagues. Perto from the Dora Nova company. Perto, please connect.
Yes, hello all. Let's start the presentation.
Yeah.
Hopefully you are able to see it now. So first of all, thank you for the organizers to give us the opportunity to give some insight from Finnish in situ remediation cases and views from a Finnish in situ contractor. So my topic is in situ remediation case examples from Finland, and to show you the agenda for this rather brief presentation. So first few words about the company that I'm presenting, and then altogether three case examples, and all of these are from biological in situ treatment of soil and groundwater. The first being one of our oldest cases, but in the context of the area and the size of the project, that has been one of the biggest ones. So a site with chlorinated solvent contamination on a former factory area. And then the second case study is actually from the area of city of Mikkeli. So that's an old sawmill area, and there we had problems with chlorophenols in the groundwater, and that was also, or that is being treated with in situ methods. And the third case example is also a rather big one. So that's an old brownfield area, so an old industrial area which is being converted into residential area. So that's groundwater remediation in that case. So going forward, some words about the company. So My name is Perttu Mattila, and I'm the head of soil and groundwater remediation sector at Doranova. So we have two business lines, the one being biogas plants, and these are big biogas utilization plants that we do project globally, so almost in all continents. And then the sector which is our oldest sector is the groundwater and soil remediation business, and that's something we have done now for roughly 25 years. In terms of turnover, I think we are the biggest in situ contractor at the moment in Finland, but also doing soil remediation on other countries, namely in Baltics and in China at the moment. So this slide is to just illustrate you the technique. So I think in the previous presentations you already learned or heard about the different methods. Jarno Laitinen told you about the in situ, ex situ, on-site terminology, and also the possibility to use physical methods or chemical methods or biological methods for soil remediation. We have two products called Direct Core and Direct Direct, and basically the difference between these two is that with the Direct Core unit, it's a fixed system which we install on site, and that can be used for source area remediation all the way to plume treatment, for example, using different kind of reactive barriers or just cleaning the groundwater plume, for example. So with this unit, we are basically able to apply several kinds of chemical or biological treatments for decontamination of the area. Also, Direct Direct is a unit, it's a bit different compared to this Direct Core, which is a fixed system. So we install a fixed wells, but with this direct push injection unit, we're able to inject certain substrates or remediation chemicals into the subsurface in order to treat the soil, either with biological or chemical processes. Going to the cases that I'm going to show you, the first one is Chlorinated Solvent groundwater remediation project in southern Finland. And to give you some short background of the area, it's a rather big industrial site with the factory which was established in the 1960s on the area. And they use there some chlorinated solvents, namely TCE, trichloroethylene, for decreasing of metals before painting them. And firstly, the contamination was observed in '94, but it took several years for investigations in order to the process to developed into the remediation actually. So in 2006, basically the whole vast area of contamination was understood and acknowledged. And at the time, there were concentrations of over 200,000 micrograms per liter of solvents on the source area, and the drinking water limit here in Finland is 10. So you get an idea how bad condition there was in the groundwater. And that contamination was actually spreading to over 2 square kilometer area. So it was affecting a lot of household and drinking water supply on the area. And what Doranova did on that side was that we made two separate remediation phases between 2009 to 2012, and then followed by another 3-year remediation from 2013 to 2016. To illustrate you what was the technology, so all of these cases that I'm showing you are biological remediation. So in this particular case, we were using technology called IRD, or anaerobic dechlorination, which basically means that we are using naturally occurring bacteria of that area, namely the halococcoids, which will break down the chlorinated solvents into ethane, harmless ethane. And how it goes, this is just how to say it, maybe a bit more well, the process is much more it's simplified process here, but in any case the chlorine atoms are replaced by hydrogen atoms, and this is done by the microbes naturally at the groundwater. And what we do in this case is that we change the conditions in the groundwater so that the natural breakdown is possible in the groundwater. So this is the map of the area, and basically what we found out through the studies was that there were 2 hotspots on the area on the factory, and these are the source areas. And we installed remediation activities on these source areas, but then again the contamination spread from this source area to almost all directions. But based on the studies, the main groundwater flow direction was towards the arrow here. So we installed also a reactive barrier, permeable reactive barrier on the corner of the property over here. Here are some pictures from the units itself. So the idea was to inject a substrate which will boost the microbial breakdown in the groundwater, so that the trichloroethylene will eventually degrade into ethane. And as you can see from the picture, the unit itself was rather small, so it was pretty easy to place them inside the factory building. And the other picture here is outside from the permeable wall injection treatment site. So here we had some 30 injection wells which were used here for the injection of the substrate to the subsoil. Going to the results, just a few graphs from few of the sampling points. So what we can see here is the biodegradation of the 3-chloroethane into this purple one, which is dichloroethane, and then all the way to vinyl chloride, and then to ethane. And at the end, the concentrations were really low. But as you can see from the pictures, the timeline is different depending on the sampling point. So for example, this point here is presenting the source area itself. So it took rather long time to get rid of all the contaminants on the area. Monthly sampling for several years. So this is in that sense confirmed case. Then going to the second example, the previous one was an aerobic process. So this one, the sawmill area, is then again aerobic biodegradation. On this side, there is an old factory building or sawmill building, and the contamination is underneath the building. And then we have installed several injection wells and pumping wells on the area. And some background information about the contaminants. So in this particular case, we had this anti-bluing agent used for treating timber, and that has components, namely tetra, penta, and trichlorophenol. and out of which tetrachlorophenol was the main contaminant on this particular case. This picture illustrates the remedial design what we are using on that site. So basically, we have an in situ treatment unit located on the site, through which we run the groundwater on the area. Basically, we are pumping from one well outside the source area, then treating, so basically aerating the water and taking out the contaminants. And once we increase the oxygen level of the injected water, then it will eventually add oxygen to the source area. And oxygen in this case is the limiting factor. So basically there are university studies showing that if we increase the amount of oxygen on the soil, on the groundwater, then the biodegradation will boost rather rapidly. So the idea is to change the conditions on this source area and get the microbes break down the chlorophenols. Then again, showing you some of, one thing we did also in addition to this pure aeration of the recirculated water, we also injected chemicals which will add oxygen to the water. So in this case, it was calcium peroxide component which was injected using this kind of a injection unit inside the factory building to the subsoil, and that chemical will slowly increase the amount of oxygen in the groundwater. So also in order to boost the microbial breakdown. In this case, this is also a project which is still ongoing, but here are some of the results or process that we have obtained from this case. So this is the initial tetra and pentachlorophenol ratio, which indicates the amount of biodegradation happening on the site. So this is before any activities took place. And from this picture, you can see that already the progress has been rather good here on the source area, but there are still somewhat high concentrations on this plume area, since the groundwater is mainly flowing to this direction here. And this last slide is from 2018, so still there is work to do, but at least the conditions in the groundwater have improved rather well from compared to the time before the in situ remediation activities. So this is an aerobic process using fixed wells and also direct push injection of oxygen releasing chemicals to the source area. So also a sort of several different methods applied to one project. Third example, this is a brownfield site where the groundwater is contaminated with chlorinated solvents. So in this case, it's an old brownfield, old industrial area with 100 years of operations. There has been a lot of excavation works done during the years, but also still the groundwater is contaminated with chlorinated solvents, and the area impacted is over 9 hectares. And what we did in this case was that we injected or used this anaerobic biodegradation process once again, as in the first example. And the difference for the first one is that we use direct push injection. So basically there are no fixed installed wells. Instead, we used the injection rig and injected this kind of IRD substrate, so-called food for the microbes, in order the micro degradation to increase. in 2019, on the area of over 1.4 hectares, over 400 injection points altogether. And these are the photos from the site work. So you can see here the injection rig and then the injection unit that we are using. And some results from this case, we are still taking monthly samples from several groundwater wells, but what we can see in every sampling point is that the amount of contaminants is decreasing relatively well in all the sampling points. So we can see that the PCE is breaking down to TCE to DC and all the way to DC, vinyl chloride, and then to ethane, and then the total concentrations will go down. But this is also in a phase where we are still monitoring the results, although the field works have been accomplished. Then this is my last slide, just to give you some lessons learned in Finland, how I see it. So as you have seen from the previous presentations, in Finland, at least I see that there's really high increasing interest towards the sustainable remediation methods. What you of course need to take into account are the economical, social, environmental aspects. Another thing is that we are using risk evaluation or risk assessment based model, so that we are not always binded to threshold or guideline values given in the legislation, but to do site-specific risk evaluation. Another thing is that since these are rather complex process and projects, we tend to utilize the know-how of key experts from different companies. So in Finland, we are using a lot of cooperation with consultants like Ramboll, who have a certain expertise, and then again we are using also some foreign companies who are expert in, for example, producing microbes for bioaugmentation and such. So it's a combination of different companies doing or targeting for one task to resolve the problem. And what we of course need to understand are the pathways, the potential risks. It's crucial that we target the remedial actions in the right place at the right time. So in most of the cases, for example, the 3 that I showed you now, in all of those we have done lab piloting, where we verify that in lab scale this degradation, biological degradation, is possible. Then we have done a field pilot to test the technology in a small scale on the field, and then going to a full scale remediation. So I think that's a good way in a challenging sites to go from small to large approach. And since we are especially concentrating on organic contaminants, there might be also heavy metals, for example, so it always needs some sort of a hybrid remediation method. So not just one, like biology or chemistry or excavation is possible, but you need several different remediation technologies applied at the one project site. And the importance of pre-investigation, I cannot underline this more. It's really crucial to have a good understanding what's happening on the site before you do any planning for the project. Basically, we need to be prepared to reevaluate the design, so that during the remediation project we might be able to change or adjust it based on the results. And then then again also reevaluate the target. So that's also something that we might need to do when applying in situ remediation technologies. Okay, so that's my presentation, and here are my contact details. So if you have any further questions, don't hesitate to call me or send email. Thanks.
Thank you, Terpo. If you allow, we will place our presentation on our website. And our final speech will be made by Mr. Reshetov, head of Technoterra company. Yes, we can hear you now. Well, it's a big honor to speak the last. Being the last, you have to sum up all the previous presentations, and you have to somehow blend them in with your presentation. So can you hear my presentation? Yes, we can. I will begin with this slide because, as Mr. Srebritski said, gilding was the first environmental catastrophe in St. Petersburg. When mercury was used to gild parts of buildings, a lot of workers died. At that time, there was no possibility to think of the environmental damage, and that's what we are doing now. We are sorting out the problems with the environmental damage. So I will not repeat the situation in St. Petersburg. I realize that you are tired, so I will speak about the work itself. So the city administration ordered us to select the sites. We worked together with Mr. Gorky. So we identified key sites, 16 sites altogether. And we did some sampling there to assess the soils in residential areas. In 2019, there were 8 areas, then 3 more areas were added. These are parameters we control: heavy metals, oil products, polyaromatic agents, and PCBs and PCDDs, PCDFs. We selected areas in residential areas because our target was not to control acting industrial companies, but to control residential areas and the level of contamination there. So our results are a bit different from those shown. And Andrei Vladimirovich told us about different approaches which can change our perception of the oil contamination results. So you see residential areas, people are in good health there, their life expectancy is quite high. However, we see that these areas are quite contaminated. We can continue monitoring. I hope that city administration will support us. If we speak about organic compounds, I can tell you that maximum allowable concentration is exceeded, which sounds quite bad, but anyway, there are no any fatal consequences for people living here. By fatal consequences, I mean direct impact. We have only translocation Impact. We do not grow anything here. We do not grow wheat here. So the impact will be different. So we use such a parameter, the level of transgenesis. You see, the situation is different. Cancerogenesis. So in more contaminated areas, cancerogenesis is higher. Our work is not dedicated to liquidation of the catastrophic consequences like we saw after gilding of the dome of the Kazan Cathedral. Our task is to identify and manage the risks and to help the city administration develop a proper policy to send money towards the most vulnerable areas, because you know it's quite impossible to decontaminate the entire city. Speaking about organic substances, the northern area is more contaminated. We identified 13 areas, and we see that the northern areas are contaminated more due to some historic factors. Heavy metals. If we compare concentrations with baseline ones, we will see a huge difference. Polyaromatic organic compounds are seen here. Benzopyrene in the first place. Oil products are here as well, but oil products are natural components, and benzopyrene is a product of technogenic processes. High contamination with oil products is seen in places where these oil products were used. As for benzopyrene, it contaminates the entire territory. And I will show you why benzopyrene is more dangerous than heavy metals. We know that arsenic is dangerous, but not many people think of benzopyrene as a dangerous component. We try to take into account the regions and the possible error factors. So you see the central region, Primorsky region. This is dynamics. For years, unfortunately, the dynamics is continuous. Why so? Industry is going down, but we have more and more cars, and this improves, and this enhances the situation with contamination. You see in the central district, the dynamics is the highest one. Conclusions are the same as Mr. Serebritsky made. As of today, the priority should be given to organic substances and not to heavy metals. However, we still have to control the situation with heavy metals as well, because some contaminants accumulated in the soil long ago. It's the very beginning of the St. Petersburg history. Moreover, in the city, we have some sources from which these contaminants penetrate adjacent territories. We believe that underground water, atmospheric water distributes these dangerous substances. These sources may be old landfills or reconstructed industrial sites, which requires sanation. The situation is very similar to what our Finnish colleagues showed. So this is quite an international problem. A lot of presentations were dedicated to petrochemicals. I will also mention them. Here we work with our design bureau from Sfera. They develop design documents for us to recultivate landfills. It was very pleasant to hear that everybody except for Yuri Datsenko cooperated with Technotera and we had joint seminars with Dora Nova in St. Petersburg, and Rambol was our client at some plants. And the company which decontaminates soil in the Baikal area also cooperated with us. So now I will tell you about our work with petrochemicals and oil pollution. For 15 years, well, we are quite a young company. We have been at 100 industrial areas of different purpose: aviation, railroad, oil treatment, petrochemicals, warehouses. Unfortunately, all of them were quite dirty. When we see petrochemicals, we see contaminated soil. It can be either a heritage of the Soviet time, when environment was quite neglected, or due to a bad condition of equipment. So let us speak about our methods. Well, they are quite similar to those described before. When we see petrochemicals, just as Rambol and Doranova companies, I believe that we have to assess the source of contamination. We use quite a lot of methods. Of course, all these surveys are much cheaper than liquidation. In Finland, in Mikkeli, we saw how much money is spent. We actually calculated the price of contamination liquidation, and the price was about several million euro. So this is the level of harm. So before we start liquidating contamination, we have to identify the source. We have to decide where to go. So these are methods shown in this slide. It's pleasant to say that this is a joint work carried out with FCG company. And this work was done due to the order of the Helsinki Commission at the Leningrad fishing base. So we identified the sources of contamination, localized them using gas chemical survey. Due to this, our work of liquidation was quite successful. So we also use chromatography. This technology allows us to say whether contamination is new or old, and what kind of contamination we have. Colleagues stated that every contaminating company claims that it's not her to be blamed, that this is an old contamination. So chromatography helps us to identify when contamination was started. After we localize the source, we have to understand the dynamics. We have to understand the direction the contamination is spread. So this winter has brought more snow than the previous one. So we can say that the level of groundwater in St. Petersburg will change. So the dynamics of underground contamination distribution will also change. So this is a diagram we build to show how contamination will move. So it's very flexible, it's changing all the time, but we can forecast how it will be moving and drill wells exactly when needed, where required. If we overlay the map of contamination direction and wall tanks, we will see which one is the source, and we can decide where to install the physical lateral drainage system. In order to understand the scale of contamination, we take samples at different levels in order to understand how concentration is coordinated, is related to depth. Then we build 3D pictures, and based on the concentration coefficient, we can decide how to liquidate these leakages. We have the same problems. Our clients want us not to disclose information. We sign disagreements with our clients because our clients finance the sanation of the territory, and we promise them not to disclose information. Well, it's clear that here we have started from there. Also, we can place 3D diagrams under the reservoir fleet in order to understand how underground water is contaminated and how it moves. Pay attention, there is a railroad here, there are some unload estacades, and this is always a high risk source. So this is the project we performed by the order of Helcom in 2013. This work allowed us to move up to a higher level. So I do hope that this seminar will also be useful for many people. These are oil-based, these are petrochemicals, and the combination of different technologies, geophysics, geochemistry, geogeology, helped us to identify the highest concentration of contamination and decide on the methods. And we understood the nature of this contamination. This is a new territory, backfield. Before, it was a coast. And petrochemicals are migrating towards the river. and we are able to understand the roots of migration. So this technology is quite nature friendly. We are not using aggressive substances. We use bacteria which destroy molecules. Of course, there are different conditions to meet, the amount of oxygen, temperature, and so on. The contaminated territories are quite large, so the volumes of introduction of chemicals are also much bigger than shown before. Decomposition of petrochemicals, it's quite obvious, so I will not dwell upon this. Thorough preparation surveys allow us to make an optimal decision depending on the situation, how many wells to drill, where to drill them, and so on. So if contamination looks like this, unfortunately, we have to drill 4 wells. If we have only 1 spill, we can drill 1 well only. So all this work allows us to effectively use decontamination technologies, which sooner or later, in a couple of years, will bring positive results. We plan to continue work on this side. I don't think that 1 year will be enough to complete the work. I think it will take us a couple of years to get a good result. Dora Nova showed us that 5-6 years is required to decontaminate highly contaminated area. Physical decontamination is also widely used, of course. I would like to sum up with the following. All these technologies are quite obvious. Identification of contamination. It's quite easy. No drilling, no construction is required. Then we have to identify the reason, the age of contamination, its scale, composition, and source. If we don't understand the source, we will not be able to curb contamination. If petrochemicals are quite old, I think that it will be easy to solve this task. But if new, fresh petrochemicals are supplied every time, most probably we will not solve the problem within 5 or 10 years. Then we have to understand the territory and the route, whether contamination is stable or migrating, what is the dynamics of the groundwater and so on. Then we have to select the method. If petrochemicals are close to the surface, we can simply take them out. At some helicopter plants, we took pure kerosene from the wells, out from the wells. Well, if we simply can take it out, there is no use to use chemical methods. So where do we put contaminated soil? We use thermal processing methods in Kolsky Peninsula. It's a thermal treatment. The cost results on the cost depends on humidity a lot. So if it's quite humid, maybe there is no point in burning. There will be benzopyrene, there will be waste, and the burning will be quite costly, which is not economically feasible. We believe that biological treatment should be used only we have a small scale contamination and we need to get a really good result, and we cannot take petrochemicals out and they're scattered around the big territory. And I agree with Zoranova and Decaprom companies that we have to monitor quality continuously. While it's good to grow wheat to see if the result is good or not, but maybe it cannot be performed in all the regions of Russia. Quality control allows us to optimize our work, to decide on the efficiency of the processes, and to introduce changes. And some people still think that there is Russian physics and mathematics, Finnish physics and mathematics, and so on. Our today's seminar showed that this is not the case. All the sciences are the same in all the countries, and all the technologies work in the same way, and we are using them effectively. Thank you indeed. Soil decontamination is not only technologically difficult, it's quite costly. And in St. Petersburg, it's also quite costly. The money is provided by the city administration. It comes from the city budget. So I'm interested in the opinion of Ms. Maria Sherbakova. Maria Dmitrievna, please, can you provide your opinion? Dear colleagues, glad to welcome you to the seminar dedicated to a very important topic, soil decontamination. There are certain questions requiring legislative initiatives. So we have a working group in our commission from 2017. We developed a legislative act. Currently, it's under agreement supported by the Legislative Assembly. We would like to establish a dedicated body responsible for the nature use and protection of environment. As for financing, we support all the initiatives related to improving the life of our citizens, making it more comfortable. So we spend a lot, hundreds of millions of rubles. Of course, we need to do prevention, to develop new technologies, and we always support such projects. We understand that it is very important for St. Petersburg and for our neighbor countries. I would like to thank our Finnish colleagues for sharing their experience. It's very useful for both of us. to solve questions important for both of our countries. We are good friends, and thank you very much for sharing this valuable experience. Definitely we will use it in developing our technologies and methods. Finally, I would like to say a couple of words. Of course, our seminar was dedicated to biological ways of treatment. But for St. Petersburg, unfortunately, we do not use in situ methods a lot to decontaminate soils in this city. The results of expert evaluations show that we have a lot of contaminated soil. When we modernize former plants, we simply take the soil out and transport it to landfills and do not decontaminate it anyhow. I do hope that experts which spoke today will help our city to develop proper programs to decontaminate these soils. I think that now I have to give the floor to Saya to sum up. Boris Alexandrovich, I would like to say a couple of words. Ivan Alexandrovich. Sure. So I would like to give a small bonus to all the conference participants. You know that in St. Petersburg on the 23rd, 24th, 25th of March, there will be a huge forum, Ecology of a Big City and Ecology of the Baltic Sea. You know that it's a large-scale event. You participated in this event many times. This year it will be difficult to participate personally, but we've heard a very interesting information that EXPOFORUM can give you a 50% discount to represent your companies at our exhibition venue. So if you are willing to do so, please connect EXPOFORUM. But this bonus is offered only to the participants of this webinar. I do hope to see you in the business program. I would like to remind you that we will have an online mode provided as well, so you will be able to make a presentation on the internet. So if you are willing to make a presentation, we will be glad to see you. Thank you so much. Saya, now it's your turn. Final conclusions from our Finnish colleagues. Saya, we cannot hear you. Thank you for the invitation to EXPOFORUM, Ecology of a Big City. Definitely we will participate somehow, and I would like to thank everybody for wonderful presentations. We've heard a lot of important information, and what is also important, that our cooperation continues. This is what is important indeed. Thank you. Thank you, dear colleagues. We wish you good health. Let God relieve you from coronavirus and other diseases. And I would like to remind you that all the presentations will be uploaded to our website. Could you please show the website? You see ecological information for enterprises. There, you can find all the information about our projects, cooperation with enterprises. So this is quite an effective tool, this website. If you want to place your information, we will be glad to do it. Once again, thank you everybody, and I wish all of you good health.